How to make it look like this? Take an x out. So then what's left? It's got to be price. It's got to be, because then it's in the right form. That happens so often in math. Put it in the right form, the pieces jump out at you. Thank you.
Mm-hmm.
So that's, what else did they say? Use it to find the price if they want to sell 420 items a day.
So we times this.
So if I want to sell 420 items a day, I'll put that in there.
Yeah.
And then to see what the price should be so they can sell that many. So this is exactly the kind of formulas all companies have. They all have formulas like this. They say, well, we didn't make many. We don't want to sell too many, so let's set the price up because we don't have that many. If we bump the price up a little bit, then I'll sell less. That makes sense, doesn't it? If you take the price down a bit, you'll sell more.
Yeah.
So if you made like, oh shit, it's like all those stupid car commercials. We ain't got too many cars. Oh, so they take the price down so that they'll sell more. Yeah. After bumping it up before.
Does this work for the same way if you're dealing with percentages of sale or something like that as well?
What's that?
If you're dealing with percentages of sales, it works the same way?
Yeah, you can start, now this is very basic. You can start doing a lot more complicated stuff.
So like if
But this is the basic idea.
you're making 10% of, or 15% of whatever, you still do the same thing.
You do a very similar thing, yeah.
I have a question.
Yeah.
Number 4A on the practice test. I just don't understand why, I don't remember adding different variables, their powers together.
Yes. Because what's degree defined to be, and also why does it make sense? Degree is defined to be the number of variables that I see in a term, right? So the degree of the first term for that one would be what?
4A.
Okay, well, now, what's the degree of the first term?
It's
2.
2.
No. How many variables? 3. I see 2 A's and a Y.
It's
So
3.
this is the third degree.
And then the other one's, okay.
Now, not to confuse the issue, but if I have A squared and Y, and the whole idea of degree is how quickly this is going to grow. So, you know, if I had an x cubed plus 1 function, for example, and I know I'm kind of being, hopefully you guys are kind of, if I have this function and I have this function, x to the 5th plus 1, which one's going to grow faster?
The 5th.
X to the 5th, yeah.
So I can just tell a colleague, I got a 5th degree, and that gives them an idea of how quickly it grows, right?
By 5, right?
Well, a rate of 5 and a 1.
Rate of 5.
So it's a 5th degree thing. Versus a 3rd degree thing, this is not going to grow as quickly, is it? Because 2 cubed is 8, but 2 to the 5th is 32. Oh shit, this is already getting big,
So the
right?
next one would be your 4th degree.
Next is going to be 4th degree. But now, real quick, when I start putting letters together, different letters together, to get a feel for why this is still 3rd degree, what if I said y equals a? What if I let them go at the same rate? Wouldn't this become a squared times a then?
Yeah.
Yeah.
If y is 8 and this is a cubed?
Yeah.
So it still gives the same idea. If y and a are both growing the same, then overall that piece would be growing at a 3rd degree. And this piece would be growing at 3 y's and 1 a, so like you said, 4th degree. Now, do you have to really understand everything I just said to get that? No. The degree is add up how many variables I see in a term.
It would help if you understood, though.
Yeah, I kind of want you to see why math people say things the way they do. There is a reason. We don't just go, not everything we do is to mess students up, right? In fact, none of it is to mess students up, really.
Liar.
But now, nuts and bolts wise, this is easy as hell. Really, I mean, if I had A7, B4, X2, Y, what degree is that?
7.
No, it's a 13th degree.
14th.
14th degree.
14th degree.
Because I see 7 A's, 4 more B's makes 11, plus 2 is 13, plus the 1 Y is 14 total variables. So it's a 14th degree.
Yeah.
And monomial.
I didn't know.
Monomial, I love it.
I'm glad you asked. because
14th
I was
degree.
thinking it was like that too. The way
Yeah,
you said it,
monomial,
but
wrong.
when you-
Okay, so that,
Now, what's the degree of the whole polynomial?
that's binomial.
Okay, it's a binomial. What's the degree of the whole?
Four.
Fourth degree
Then
with
you
closest
have
to
all
The highest I
negative
see is 4.
four degree.
Right.
So it's a 4th degree
Binomial.
binomial. Now, why don't I just add the 4 and the 3? Because these are not together.
Yeah, so
This
you-
is all together. That's why I add up all that. Are these together?
No,
No.
so you make a sum.
I just see which one's
Okay.
biggest. Because really, I mean, when it gets really big, when x is 3 billion, how important is 1? Not. right? If I had $3 billion and $1 dropped out of my pocket, I'm not gonna be nearly as worried about it as I would be right now. If I drop $1, you know I'm all over that thing.
If it is A2 and Y3, it will be.
If it was a squared y cubed, it would be the fifth degree.
degree.
Exactly. Because there's 2 a's, 3 y's, there's 5 total variables. Right? Don't say there's a's and y's, there's 2.
And the leading.
Count all the variables together. That's what a degree is. That's all it is. Degree is easy. Don't let it be hard.
And the leading coefficient is the number with
Yeah.
the biggest one.
The leading coefficient is the number in front of the highest degree term. So in this case, the leading coefficient would be -4. So that's, leading coefficient is a good example of when I don't say shit about something, because you guys are supposed to be reading your book too. This comes from the book. You can ask me a question about it. In fact, I expect a question sometimes, but this leading coefficient would be this because it's in front of the biggest degree. That's all. It's the most important term, so that's the leading coefficient. Cool. Let's see. What about the chapter on substitution elimination? Normally, that's decent.
The graphing, go with the graphing.
Can you show on your practice test, page number 3A?
Okay, good. So here's a graphing example. So this one's not too bad because I already did what with these equations. Why is this one pretty easy?
Just one
Sorry, why is this?
They're already mx plus b, right? So that's all I really did was I took the first guy. What's the first guy's y-intercept?
Starts with 3.
3. Okay, so here's 3.
Okay.
And then what's the slope tell me to do?
Down 2 over 1.
Down 2 over 1, down 2 over 1. So you do several of them, right?
Right.
Good Lord, Jeff. You're all crooked. All right. Down 2 over 1, down 2 over 1. Okay. Weehaw! Sound like that's straight?
Okay, the other one is -5.
Yeah. And that's why you step, because if you're a bad drawer like I am, then putting those dots will make it very concrete, right? If you don't put those dots and they cross, you're like, where the hell is that? So now what's the other guy tell me?
-5.
So this is number 1. Yeah, -5. And the slope tells me to go
2 up and 1 over.
up 2 over 1. Up 2, and now I'm already off, aren't I? How the hell did I do that? 1, 2, 3, 4, 5. 1, 2, 3, 4. Oh, I can't count. That's the only problem. It's not that big of a deal. 1, 2, 3, 4, 5.
Okay.
Cool. So up 2 over 1. Up 2 over 1 there. I can see that they meet right there.
Yeah.
The dot went right on top of the other
They
dot.
would be at 2, -1.
Yep, good.
And when you ask a problem, you want that documented on a paper like that?
So if you don't put this,
Then it's wrong.
then it's not quite complete.
Okay.
You showed me visually where the answer is, but I want to know what the answer is. 2, -1. That's the point that they meet at, right?
So there's no equation adding, subtracting with the 1 and 2 up there?
Sure.
No, that's how you do it algebraically. This explains why the answer to a system of equations is always a point. Because what's the basic idea? It's where the two lines meet.
And then
So I could do this algebraically, right? I could do substitution or I could do elimination. And real quick, if I did substitution, that's the easiest way to do it because what's y?
It's that.
It's that. So here,
You just put it in.
so if I want to do it algebraically, which I don't ask you to do on this problem, but if you wanted to, you'd have -2x plus 3, plug in here, right?
Yeah.
Equals 2x minus 5.
Right.
So you could add 2x, add 5, you get 8 equals 4x.
Right,
Divide by 4.
-2.
Jeff, x is 2.
right.
Plug 2 in.
Thank God, so far so good. Now if you plug 2 in, y equals -2 times 2 plus 3, y equals -4 plus 3, y equals -1.
You
Kick
can
ass.
do a table too, right?
Sure. You see?
Cool.
So there are, the funny thing is, almost every level of math, there's an algebraic way to do something, and there's a graphical way to do the same thing. And sometimes, some of the harder problems in math, it's easier if you put it graphically, believe it or not. Might be this disgusting ass graph, but it looks a lot better than the equations do, so that's nice we have two different ways to do it.
I know,
This is -2 over 1, right? So if I rise -2, that actually is falling.
No,
And then-
I mean, like on this side or that side, like you use the graph. How do you know when to go this way?
Oh, it's just because if this is positive, I'm going to run positive direction, right? Now, I could do this as 2 over -1. And you see, if I start here, don't I go up 2, back 1? So if the bottom is negative, that's going back. Because it's going negative direction. So if the top is positive, you go up. If it's negative, you go down. If the bottom is positive, you go in the positive direction. If it's negative, you go back. Cool. Rise or fall, run or go back. Good. I think you touched almost everything. Basic exponent ideas, right? The properties of exponents. Solving system, graphically, elimination, substitution. And then like terms for the polynomials, right? Multiplying them out and then factoring them.
Are you gonna do 3 variables like for?
If I do, it's going to be bonus because I made that bonus. Made that extra credit, yeah. So I might have a 3 variable dude as an extra credit problem.
But what about setting like the applications with the 3 variables?
That's what I'm saying. If it's a 3 variable problem, it can only be bonus. Yeah. Okay.
Okay.
That's all I got.
Okay, me too.
All right. You guys get the email about the factory workshop this week. I'm doing the one tomorrow, actually, tomorrow night.
Tomorrow night, 5:30?
5:30, yeah. All right.
Why would you say, like I know exactly what I wanted to say, but I didn't write it down properly in here. What I meant to say, like, I kind of picture it, you know, like if you see like that, you know, it's on the same line. I just don't know how to explain it.
Yeah, I kind of knew what you were saying. But you don't, if you say on the x-axis, it's sort of like this is on the x-axis, this is on the x-axis, but that's a function, right?
Oh,
What
okay,
you
so-
really mean is there's one spot on the x-axis that goes to 2 different spots, like what you just drew, right? So you want to say it like that. If there's place on the x-axis that goes to 2 y's,
Okay.
2 locations, then that's not.
Oh,
So really the direct way to say it is, if it's a function, if there's no x that goes to more than 1 y, that's really what you're trying to say.
oh,
No
okay.
x on the
Okay.
x-axis that goes to more than 1 place, more than 1 y.
Oh, okay. Okay, I was just the.
How do you use the class before? Did you do the assessment then? What is that? You don't know. Okay, well, I guess it said this, because you didn't tell me you were in the wrong class. But if you did place into a class, you never have to take it, you can always take it off. But you're right, I really think, from what I've seen, I think you need that little extra practice, so. Yeah, you're gonna have to either this summer or sometime take the one below. Yeah, that's the way you do it.
Just drop it in there.
Yeah, yeah. I think, it's already past the 8-week point, so there's no, I don't think we have an 8-week math knowledge. If we did, we could probably do that one.
Okay.
But it's probably too late, it's definitely too late to study it on the full stuff. Okay, that's what you should do.
Okay.
Six, 7, 9,